Hi, I'm Paul Battaglia, and this is section 3.2, Logarithmic Functions and Their Graphs. So with logarithmic functions, we need some way to motivate the lesson, I think, because logarithms and just even the word logarithm can be abstract for students. So I'm joined by Gabe and Brittany. Gabe, tell me some things that you would do to help motivate the students to learn about logarithms.
So I like to start this section by maybe throwing out two equations. So something like x squared equals 4.
Okay.
Students have seen this equation before.
Yep.
They know how to solve it. It's pretty straightforward. But then I like to tweak that equation just a little bit and have them think about something like 2 to the x equals 4.
Okay.
So turn it into more of an exponential equation.
Yep.
And say, well, we can solve this using methods from the previous section,
Sure.
or even just guessing and checking real quick. But then I like to throw out an equation, something like 3 to the x equals, 702.
Okay.
And what students will see is, okay, well, maybe we can start to guess and check our way towards an answer.
Take a long time.
But we're never going to really get an exact answer.
Also true.
And where I go from there is, well, let's go ahead and let's introduce this idea of the logarithmic function.
Okay.
So the logarithmic function I like to introduce, at least, as sort of the inverse to an exponential function.
Okay.
So that's one of the properties of these logarithmic functions. Right. And then from there we can have this conversation about what a logarithmic function is.
Okay.
We can talk about the other three properties. So the one-to-one property, saying that the log base a of a is equal to 1.
Okay.
Log base a of 1 is equal to 0.
Okay.
And then from here we can maybe apply some of these properties to find the graphs of logarithmic
functions.
And
you know, before we even talk about the graphs, I think it's so interesting because now students know, what a logarithmic function is, but they actually might still ask the question, what is a logarithm? Why are we using this word, right? So one of the things I'll even do with my class is I will actually say, let's get out our calculators, even if they're scientific calculators. And I'll say, pick a number, any number between 10 and 100. So you cannot pick 10, you cannot pick 100. So any number, write it down so you don't forget it. And let's just suppose they pick, 31, right? So the objective is for them to try and raise 10 to a power that gets them 31, okay? And I'll have two students give me the numbers they picked. And then what we'll do is we'll use the numbers they got as exponents and try and illustrate the properties of exponents with their numbers. And so what I'm looking for is that aha moment so that once they've done this, I can ask them simply, so what is a logarithm? And the reply I'm looking for is for them to just say, oh, it's an exponent.
Yeah,
because that's really all it is, So let's get back to the graphs. Brittany, tell us a little bit more about what you want to do with the graphs.
All right, for the graphs, again, we're going to take it back to other previous sections that we talked about, saying the transformations of the graphs, same thing for the logarithmic functions.
Okay.
And then also being able to find the domain and the range.
Okay.
Same thing that we've been seeing.
Right.
But along what Gabe was talking about with the inverse and everything, showing them that the logarithmic function is an inverse of the exponential function. We can show that through the graph too. So we can say, well, the exponential function had horizontal asymptote at y equals 0.
Right, okay.
And then now with the logarithmic function, we have the vertical asymptote at x equals 0.
Okay. So there's that inverse relationship again, right?
Yeah,
Exactly.
Exactly. And then again, with the domain of the exponential function, we could have all reals. Well, then for the logarithmic function, we're going to have the range be all reals.
Okay. So constantly reinforcing this inverse idea and things switching basically back and forth, which is perfect. Good. I think one of the other things we have to talk about with Brittany, we talked about domain, right? So the last thing we do is we say, how do you find the domain of a logarithmic function? And so when we do that, something interesting comes up, and it's something that I'm pretty sure students don't quite know about, and a lot of teachers too. And it's the idea that when you express a logarithm, you have the word log, or the abbreviation log, you have the base, and then you have the answer being the exponent. But what do we call that quantity attached to the log, right? And that's called an argument. And knowing how to use that term is very helpful as a teacher, because what you can do is you can tell your students, now if, like Brittany said, if the domain now is no longer all reals, how do we go about finding the domain? And then we come to see that it's really that argument that has to be greater than 0. So these are all important things, I think, to help point out to your students as you go through section 3.2. I hope you found all these tips helpful and that you have much success in section 3.2.